Today, cooling a building feels effortless. With the press of a button, air conditioners quietly control temperature and airflow. However, for most of history, this technology did not exist. Buildings still had to remain usable, comfortable, and breathable, especially in warm climates. Before air conditioning, ventilation was not a luxury, it was a necessity. In this video, we explore how buildings were probably ventilated before modern air conditioning systems became common. Before air conditioning, indoor heat could easily become overwhelming. Without proper airflow, rooms likely felt hot, heavy, and uncomfortable. Fresh air was generally needed to remove heat, moisture, and stale air. Buildings that failed to allow airflow probably became difficult to use during warmer periods. As a result, ventilation was considered a core part of building design, not an afterthought. Comfort probably depended largely on how well air could move through a structure. One of the earliest ways buildings managed ventilation was through careful orientation. Structures were often positioned to take advantage of prevailing winds. Windows and openings were probably placed where breezes could naturally enter. Sun exposure was probably considered as well, since direct sunlight increased indoor heat. By adjusting orientation and layout, builders generally reduced heat buildup and improved airflow without using mechanical systems. Windows played a central role in natural ventilation. They were not only sources of light, but also pathways for air movement. Opposing windows were often used to create cross-ventilation, allowing air to enter from one side and exit from another. Higher windows were probably placed to release warm air, while lower openings likely allowed cooler air to enter. This continuous movement of air generally helped regulate indoor temperature throughout the day. Many buildings probably included courtyards or open interior spaces. These areas probably acted as natural ventilation hubs. Air probably flowed freely through these open zones before circulating into surrounding rooms. Buildings connected to courtyards generally benefited from better airflow and reduced heat. Passageways and large door openings were often aligned to support this movement, creating a steady exchange between indoor and outdoor air. Vertical airflow was another important element of ventilation. Since hot air rises, many buildings probably included roof openings, vents, or elevated structures to allow heat to escape. Towers, chimneys, and roof gaps were probably designed to release warm air naturally. As hot air exited from above, cooler air generally replaced it from below. This process, while simple, probably played a major role in keeping buildings usable during warm seasons. Building materials also influenced ventilation and temperature control. Stone, brick, and clay were commonly used because they absorbed heat slowly. These materials probably helped stabilize indoor temperatures by reducing sudden heat changes. Thick walls probably delayed heat transfer, while open interior layouts generally allowed air to circulate more freely. Construction choices were likely guided by long-term comfort rather than short-term convenience. Ventilation worked better when combined with shade. Roof overhangs, recessed windows, and covered walkways were often used to limit direct sunlight. Shaded surfaces probably stayed cooler throughout the day. By reducing heat entering the building, airflow became more effective. These passive cooling methods probably helped buildings remain comfortable even without mechanical systems. Ventilation was probably built into every aspect of construction, from layout to materials. While modern technology now controls indoor environments precisely, earlier buildings show how architecture adapted intelligently to climate.